Okay, we are recording. Hopefully there won't be a crash this time. Actually, the funny thing is the crash last week came at a good time because I completely forgot I had a scheduled appointment, just a phone call. And if the system hadn't crashed and I made sure that last week's recording was a short one, I would have had to take the call on while doing recording. So yeah, that actually worked out well. I hope it doesn't happen again, but that actually was curiously beneficial. Well, this week should also be short because I want to build the damn laptop. Sorry, this is Going Medieval, keys provided by Tinsley PR for Irregular Corporation. The Irregular Corporation. Yeah, so I do have the Framework 16 laptop. It came. That was on Monday. But I've had no time to do anything with it. The heck? Oh. Seriously? I don't have enough wood? I'm sure I can fix that. Growing, mature, dead, and dead. Alright. That too. So yeah, I will be building that after I take care of this. Should be fun and all that. I've got some software stuff ready to put on there. But yeah, I'm figuring it may take me a few hours to build the thing. I don't know how long it will take me to build the thing. And it'll be days of me trying to set it all up properly. Getting all the files where I want it to be, all the software installed, and yeah. But hey, at least I will have my own laptop again. Couple things that I put in my thing to write up. Put in my notes to write up. Sorry, to talk about. One that could be more of an issue than it seems to be. How's there flax over here? AMD shared this week 4 high severity vulnerabilities. What are you wearing? Alright, well, I mean, I'm inside. Okay, and you know what? We're good. 7. So somebody can do that and be inside. Brain just turned off. Sure. Environment control. Yeah, 4 severe, high severity vulnerabilities that require BIOS updates to fix. It's in the news to Agisa, because they did also, yeah, we've got fixes for this. Although, interestingly, well, yeah, I'll get to that. Actually, wait. No, I don't have anything more to say. So, apparently, these vulnerabilities have either been known about for a while, they haven't shared until they had fixes, or it turns out they've already got Agisas that fix them, because there is the AMD thing talking about it, their notice, but also there is... I linked to Tom's Hardware write-up that they did, where it notes 2 things. One is a table that shows that there have been versions of the right Agisas to fix these vulnerabilities. In some cases, they had them in October. OEMs had them in October. So if you do try to keep your system, your BIOS and such up to date, you might already be covered. You should check, though. You should check. But there's also apparently the only way for the vulnerabilities to be exploited, somebody needs local access to your system. So it's if they get, if all those other things fail, this is a big problem. But I'm sorry, I always just find it a little funny. Yes, it's high. We have a high severity issue, but people need to have actual access to your system for it to be an issue. So it's well, should be ways of avoiding that. Yeah. Then the other thing I got written up, and that's actually the last thing I have to talk about, at least in my notes, is a piece of news from Phoronix that was kind of interesting. Actually, it's very interesting, but there's a weird thing to it that some people are not sure what it means. So NVIDIA has CUDA, which is essentially a general purpose GPU system. So it lets you... There shouldn't be salt here. Yeah, salt is not allowed. There. So it lets you leverage the general compute performance of a GPU for various tasks. And there are definitely pieces of software they use that. For example, Blender uses it and use it to accelerate different things, stuff like that. So, I mean, it's a nice thing. It's also... NVIDIA has used it to great advantage. Like, CUDA is a big deal. It really is, in the right circles, where it's one of the things that NVIDIA has strong market dominance on. OpenCL and Vulkan Compute, technically also, in theory, is supposed to compete with it, but NVIDIA just has maintained market dominance, I think is the simplest way to put that. I don't know all the details there, but it's like, yeah, competitors have not succeeded. But somebody apparently had worked on something a while ago, and it was initially about even trying to see, hey, can I get CUDA to run on Intel graphics? And I'm guessing how it was being described, it kind of made me think of a DXVK, where it translates the API calls. For DXVK, it translates the DirectX ones into Vulkan. So that way, instead of a game running in having to run DirectX, it's actually can you like flee? I really don't want... Yeah. Oh, well, we actually managed to kill the thing. Okay, good. It's like, I know with that body, the dog will be fed. My brain just turned off. So, this guy was working on a way to get it to run on top of Intel graphics. And apparently Intel was like, oh, that's neat, but we're not super interested. So what ended up happening was AMD reached out. And by the way, this thing's called ZLUDA, so ZLUDA. Not entirely sure, but AMD gave him a contract. Was actually funding him apparently to develop this so that you could run CUDA on Radeon GPUs. And he apparently got it working, but AMD then decided to terminate the contract, stop funding, all that, which that may sound very silly. Why would you possibly want to end this? Well, there's a theory. Because there was a provision in the guy's contract that if the contract ended, he could release it open source. He could make the project open source, and that's what happened this week, is it went open source. And I saw some people saying that actually might have been intentional, that AMD cut funding because now they helped fund the guy when it was basically just a fun project, but as far as it becoming anything official, AMD is hands off. So NVIDIA can't complain to AMD. Like, liability stuff is removed. Now, I don't know. I just know that that's pretty neat that somebody figured this out at all. Figured out a way to do that at all. Here we go. Alright, so none of that looks terrible. Not an imminent risk of dying there. But yeah, and Phoronix did actually test it. Phoronix is Linux focused, so they're running it on that, not on Windows. But it's like DXVK, where you drop the files into the right folder, and it'll just work. So you could just drop the binaries for ZLUDA into something like your Blender folder, and now you have the CUDA pathways running on a Radeon GPU. At least in theory, that's what it would do. I don't know. I haven't tested it. I don't really feel like testing it either. I've got other things to do, like on the laptop. Also, I don't use Blender or really anything that uses CUDA, so not sure how useful it'll be anyhow. But still is really neat, and it will be interesting to see what happens. But also, as Phoronix pointed out in their thing, that in their write-up on this, that AMD already has their HIP and ROCm, so HIP and ROCm, software stacks for this kind of programming. Like, come on. I'm sorry, you there. Sorry, that just really annoyed me. They already have their things to get the most out of their, well, GPUs, yes, but also their more dedicated compute accelerators. So it's basically AMD already has an answer to CUDA. It's obviously not a one-to-one kind of thing that this, in theory, can be. But it is still pretty neat that this has been achieved. All right. Okay, I'm gonna let her get to bed now. I'm gonna save and stop because that's basically what I'm done. Oh, well, that's annoying. And I can keep talking a little bit, but I do want to get out of this properly. There. Now, one thing, I do remember years ago, AMD actually did come up with something that would convert CUDA code to HIP code, to HIP code, and that I remember, and I think it was even Phoronix I was talking about, that was saying, yeah, this is actually in some cases running faster than on NVIDIA GPUs, this conversion, so it's like, this kind of effort has been made, but it's still, I think Phoronix's point is valid, that AMD already has its own competitor to CUDA, and while that's not going to help it, and while it, that will help it try to achieve market dominance, or at least take some away from NVIDIA, it still is, ZLUDA is not as a, oh, we gotta have this is so useful kind of thing. So yeah, I mean, it's good because it could be like a DXVK is in some cases used by developers, is my understanding. Well, they'll put it in there, not because, oh, now we support Vulkan kind of thing, but as a, okay, we can now learn more about how this runs in Vulkan and start developing to Vulkan. So maybe there could be some uses there. Apparently the dude working on it had also, it's at the end of the Phoronix piece, it mentions that he's also interested, if he has the time and all that, to see if he can get DLSS to run on Radeon. And for anyone thinking, oh, you can't do that, you need the tensor cores, I don't think that's really true. Like I remember seeing something not that long ago, like a few months maybe. Somebody managed to watch the performance of an NVIDIA GPU while running DLSS, and they noticed that the tensor cores basically got hit for a very, very brief spike when DLSS was being used, and then it stopped being used, and they were like, see, this shows just how important tensor cores are. It's like, not necessarily. It shows that whatever the tensor cores are doing, they do it very quickly. But the kind of math tensor cores do, GPUs can do. Not necessarily as efficient. I mean, it's the whole, there's hardware acceleration and then there's ASIC acceleration. Tensor cores are like ASIC acceleration. GPUs still have like hardware acceleration. It's not as fast as ASIC, but it is possible because GPUs are still general enough. So I would not be surprised if somebody managed to get DLSS running, without needing tensor cores. And also, NVIDIA actually did that. There was DLSS like 1.6, I think it was called, that ran on just the shaders. Was it Control that had that? And people had it running on the GTX 16 series, which has no tensor cores. So it's like, no. You absolutely do not need DLSS. You absolutely do not need tensor cores for aspects of DLSS. That was many versions ago. That was many years ago. So things have definitely changed. But it still is in theory, yes, you could run all the computations for DLSS on a non-RTX GPU. That is simply a statement of fact because of how math works and computer hardware works. But would it be running quickly? Would it be running efficiently? That's where the question is. And so I do hope that the guy works on that, because it would be interesting to see if it was yeah, it's like half the performance of an RTX GPU, but it's still actually, for what you're trying to do, very fast. I mean, it might be, I don't know. But there is also that whole, for me, how I always consider DLSS 2 to be similar to SMAA, where it's just a different morphological engine that's a trained neural network. And it's like, if that's accurate, then it's like, I mean, in theory, you could just come up with a better morphological engine or a trained neural network one that could compete with DLSS, but potentially run on anything, because trained neural networks can certainly run on other things. It's like I'm using one right now. OBS has RNN as a noise reduction option, and RNN it is a neural network. It's a trained neural network to try to identify and filter out noise, and it's running on my CPU, right? So I'm saying, yes, you can run neural networks. You can run a lot of AI stuff on things other than tensor cores. In fact, a lot of AI can be run. A lot of AI doesn't even use tensor cores. It's like, I know I've said it before, and I know I'm just still talking. I do believe that NVIDIA, when they put the tensor cores into Volta... wait. No, not Volta. Was it Volta? Was that the one before Ampere? That was business only? Anyway, I do think that because they tensor cores were first put on a GPU architecture that never came to consumer. It was just for data centers. And I do think that when they then developed the next one, which... Oh, wait, no, that was Turing, not Ampere, sorry. Turing followed Pascal for consumers, that's right. I do think, though, that when they developed Turing, which was supposed to be the offshoot, so then, yes, that would have been Volta, that when they developed it, that they just carried over the tensor cores because they were unifying their architectures instead of having split. It's weird how that both AMD and NVIDIA seem to just undulate back and forth between, do they do one architecture for everything or two architectures? And NVIDIA's currently have one architecture. But it's just, I think that they realize, well, we have to keep the tensor cores in there so we have more chips to sell wherever. Okay, but how do we justify all the silicon? How do we justify their use? It's like, well, why don't we do this DLSS thing? And then they did that and have just been using their market dominance and mind share to convince everyone that tensor cores are the only way to do AI, which is false, and that DLSS is the only way to do this stuff, which is false. And it's just, but everyone believes that. And also that trained neural networks demand tensor cores. Because that right there is something I'm very certain is false. I mean, aside from the fact that it's, because I'm using one right now, as I said. But I just mean, I can understand if you were actually building up the neural network, that then, yes, you would need a tensor core for doing the math there. But for just running it, that doesn't make sense to me that you need tensor cores. Like, I mean, to build the neural network is one thing, to use it is another. So that's my impression. But I don't know much. I don't know a whole hell of a lot about different AI systems, and certainly not the intricacies of how they run. But it is still, as I said, neural networks do run on just normal CPUs. There are examples, multiple. So it's, yeah. Anyway, so yeah, Zilud, it will be an interesting thing to see what happens with that. But I am gonna, not even 20 minutes. I want to get to the Framework 16. I want to build that thing. Also, it's cold, so I kind of want to just get moving. So we'll see if next week maybe I will try doing a recording on the laptop. Depends on how different things go. So see you next time, and have a great week, and try to stay warm if you're somewhere that's currently cold. See ya.